Alrighty, we're in Unit 4, Part 5. This time we are on the second part of the Isosceles notes. So, just like the first set of notes, there's really one idea going on here. Last time around, we introduced the idea of isosceles triangles and then looked at their base angles and their legs. This time around, we're really just looking at bisectors. So, in all of these questions, we're going to be cutting an isosceles triangle in half. What you'll find is that when you do this, the vertex is going to be cut in half and the base is going to be cut in half. That's really it. So we're starting with a theorem, the vertex angle bisector theorem. I don't really like this one. I'm actually going to go ahead and give you a secondary definition first, and then I'm going to give you the math language. All this is really saying is if angle bisector, I should really say vertex, if the vertex is cut in half, then the base is also cut in half. And what that really means is if you're given a question where your vertex angle is bisected, cut in half, then necessarily as a result, your base is also cut in half. So if, let's say, the whole angle here was 80 degrees and you're told that it was cut in half, so that this is 40, down here, this long segment, BC, would be cut in half into BD and DC. There is some math language. I'll go ahead and read it out. If a segment or line bisects the vertex of an angle of an isosceles triangle, then that segment or line is also the perpendicular bisector of the base. This is really important. It's a perpendicular bisector. That means that if it cuts through the top and cuts it in half, it also cuts through the bottom as a perpendicular bisector, emphasizing that this makes a 90-degree angle here. That's it. So you know everything you need to answer the questions in A. Triangle CIS is an isosceles triangle with CI congruent to IS. We're told that IO, the center segment, is the angle bisector of the whole thing. So I'm gonna let you try to solve for what the length of OS, CS is, and the measure of COI. Pause and see if you can do it. Okay, so I'm told that the measure of this is 7, and that this cut my triangle in half. Since this middle line cut the triangle in half, OS also has to be 7, and the full length is 14. You might have been stuck on trying to find the measure of COI, but it's easy. Remember, we said that this was a perpendicular bisector, so this here has to be 90 degrees. We didn't even have to be given the number. No matter what, it's always going to be 90 degrees. So we have to give the converse of the vertex angle bisector theorem. I'm going to use my definition down here. If the base is cut in half, then the vertex is also cut in half. If the base is cut in half, then the vertex is also cut in half. It's just the opposite of what we did above. We cut the base in half, that means the vertex is also cut in half. Okay, on the back of this, we're going to answer some questions. I'm going to do them all, and what will happen is I will explain the first one, I will pause and then explain the second one, then I'll pause and explain the third one. Okay, let's flip over. I'm going to go ahead and do the first one myself. and then give you a chance to try C and D. Okay, question B is really simple. Triangle APB is an isosceles triangle with the length of AP congruent to the length of PB. DC, this line here, is a perpendicular bisector of the base. That means that is also the angle bisector up here. So I'm told that the measure of angle APB, the outside, is 100 degrees. Find APC, which is just this angle here. Well, this is 100 degrees. This is half of that, so this here is 50. That equals 50 degrees. Okay, pause. I want you to see if you can solve the questions in C. And I'll explain them in just a moment. Okay, triangle ABC is an isosceles triangle with a vertex of BAC bisected by segment AD. I'm told that BAC, the whole thing, is 80 degrees. That the length of AC is 10. And that BC, this whole thing here, is 12. Okay? I'm going to go ahead and fill in the rest of my information. This has to be 6. This is also 6. The length of this side is 10, and I know that this here is a right angle, so it's 90 degrees. I'm also going to fill this in as 40 and this in as 40. Okay, so let's see what I can knock out right away. AB, we already know that's 10. BD, we already know that's 6. BAD, that's going to be 40. We got to figure out the measure of angle B. That is this one right here. Well, we know that this here is a triangle, and that the sum of the interior angles in a triangle is 180 degrees. So I can eliminate the angles that I already have, 90 and 40. So I'm going to do 180 minus 90 minus 40. Okay, that's going to work out to be 50 degrees. So the measure of angle B here has to be 50. All right, go ahead and pause and see if you can complete question D. This is a tricky one. I want to see if you can do it. All right, let's try to solve. Triangle APB is an isosceles triangle with a vertex angle APB. The length of PM, or segment PM, is the perpendicular bisector of segment AB. Angle A is 30 degrees. AP is 5, and PM is 3. We have to find the indicated values. Okay, first we have to find APB. That's this whole thing right here. We actually don't need the bisector for this. Since this is an isosceles triangle, if this is 30, that's 30. Then, knowing the way triangles work, the sum of all angles is going to be 180. I have this angle, that angle, and the top. This whole top has to add up to 180. So if I take 180 minus 30 minus 30, I get 120, which is what APB has to be. Last is AB. AB is tricky. So I actually don't need any degree measure information for this question because it's a length. Lengths and degrees are not related at all. Instead, what I really need is this measure of 5 and this measure of 3. Notice that we have a right triangle right here. What formula can we use to find the missing lengths of a right triangle? That's going to be our Pythagorean theorem. A squared plus b squared equals c squared. Okay, I'm going to call 5 my c. I need the 2, the square. I'm going to call b my 3. And what I'm trying to find is a squared, or just a. All right, to square these, I'm going to go ahead and do that real quick. A squared plus 9 equals 25. Then I'm going to subtract the 9 from both sides to get a by itself. A squared equals 16. Lastly, I want to take the square root of a and find that a is equal to 4. This is going to be the length of my missing side. 4. Okay, as always, thank you very much. Please go ahead and complete this homework. Complete the homework attached to this set of notes, and then turn it into me as soon as possible. Let me know if you have any questions, and thank you very much.